Alrighty, good morning, guys. This is the first day of the last unit that we're doing in KAP. Our last unit is going to be geometry. So all these different shapes and things. We probably won't finish this unit before STAR, but that's because the stuff we do after STAR will be such great content, so it doesn't matter on this STAR. Okay. But this is the last little bit that we have to get through. Some of this stuff you know, some of it you don't. So some of it's going to be review, some of it's going to be new and blue. We're going to come back to this brain pop video. I actually like it later in the lesson. We're going to just go ahead and hop into all these crazy notes. So starting with the basics. Again, this is probably some elementary school stuff that you'll learn, but just refreshing, making sure it's on the top of our brain. So we're going to be talking about triangles a lot today. Triangles, let's break that down. Tri means 3. Angles means angles. Great, awesome. So just breaking it down even further, talking about angles. An angle is when we have two rays formed with a common endpoint. A ray is when you have one endpoint and it goes in a direction. Again, an angle is formed with two rays with a common endpoint. This endpoint you can call the vertex. And again, that's a ray. That's a ray. And then the amount that it is open is the angle. Okay? The bigger the amount, I would say, the bigger the angle. And it's called the vertex. Is that common endpoint? Hopefully nothing new. Again, a triangle has 3 of these angles. So there are different types of angles. This is probably new to a lot of y'all. There's like, you know how you can classify numbers as multiples of 4, multiples of 5, multiples of this? Yes? Sure. Okay, we have some special angles that we can say are both complementary. We can say they're either complementary or supplementary. Okay? For a complementary angle, this is talking about two angles that add to 90 degrees. Okay, 2 angles, when you put them next to each other, when you add up their angle measures, they both add up to 90. So for example, okay, I have 2 angles right here. Okay, I have the angle on the top, let's say that's going to be 50 degrees, and this angle down here is 40 degrees. Okay, if I added those 2 angle measures, I could say that they equal 90. Okay, now with angles, there's a specific way, there's like a way that we write angles. We don't just write the words, the measure of angle, blah, blah, blah. It's not that fast, okay? But I'm going to call this angle A up here and angle B down here, okay? Now, the way that I can write this with like math notation is, it's going to be weird, the measure of angle A plus the measure of angle B, okay? We use different little symbols. They will use the letter M specifically. The measure of angle A plus the measure of angle B. Okay, that is equal to 90. Another way, if you know those angle measures, we know that the measure of angle A is how much? We know that it is 50 plus the measure of angle B, which is equal to 90. So those 2 are complementary. Okay, they complement each other. They think, you're so pretty. You're so pretty. They're complementary. Okay, so let's look at an example of that kind of question. So it says if, for example, if angle A is complementary to angle B, okay, if I see that it's complementary, that means they add up to 90. If angle A is complementary to angle B and angle B is 23 degrees, what is the measure of angle A? Okay, so I can write an equation. I know you all can do this, but I'm going to write an equation. I'm going to say that the measure of angle A plus the measure of angle B, again, is going to equal how much because it's complementary? 90. Okay, I can substitute it. Do I know the measure of angle A? No, so I'm going to say the measure of angle A plus, do I know the measure of angle B? Yes, it's 23 is equal to 90. And then it's sort of like, this is sort of like our variable. We're solving for that. So in order to solve for A, I would want to get the other stuff on the other side. Sort of like an equation, I could subtract 23 minus 23 cancels out. The measure of angle A is equal to, math, 67 degrees. You'll see how I did that? Okay, it's tying in those equations that we did a few units back, and then tying in some geometry. Okay. Another special type of angles is supplementary. Everyone say that word. Supplementary. Okay. Instead of two angles that add up to 90, they are going to be two angles that add up to 180. Two angles that add to 180 degrees. Y'all know what a 180 degree line looks like? Flat. Okay, I like that. I'm used to one. Almost knocked out Tanner. Okay, so for example, I might have it's going to be basically a straight line. Okay, and then two angles. Let's say one of them. Let's say one of them is someone give me an angle number. 110. Thank you, Miss Lytle. Okay, and Miss Lytle, no, no. Sorry, my math mess did not say that because this one's 100. This one is 110, and then this one would be 70 degrees. So good with that? 110 plus 70, that would equal 180. Okay, if I wrote my equation, let's call this angle 1 and angle 2. The measure of angle 1 plus the measure of angle 2 is equal to 180, and that is true here. Okay, sometimes they don't give me a question, they just give me a picture, and they're like, find X. Okay, it doesn't even tell me if it's complementary or supplementary. How would I know anything about this picture? Carolyn? Because it's a flat line is going to be 180 degrees. So I can write the equation. What's an equation I can write? There's a couple ways you can write it. To solve, sort of like how I have over here, what's an equation I can write for this side? Okay, let's try it out. Very good. The measure of angle X plus 130 is equal to 180. Solve, balance the equation. Subtract what from both sides? Good. And I'm going to get that the measure of angle X is equal to 50. Gucci Gucci? Gucci. Okay. So those two words are sort of new material. Question? Stretch. Okay. So already in your mind, you're probably like, how can I remember supplementary complementary? I have a cute way. You're welcome already. Okay. So complementary starts with the letter C. Very good. Complementary starts with the letter C. Supplementary starts with the letter S. Awesome job. Welcome to elementary school. Okay. So I'm going to do some magic. Are y'all ready? Are you holding on tight? I don't see y'all holding on tight. Maybe hold on tight. Okay. Complementary again adds up to 90. You ready? Ready? Y'all ready? There's more. Y'all ready? Supplementary adds up to. You ready? You ready? Wow. Yes, you can use that. Just make sure you give me credit, like street credit, like yeah, Miss Lytle. Taught me that. She taught me all I know. Okay. Nothing crazy. That's just the way that I literally honestly think about that. That's how I remember. Okay. Oh, complement 90. Okay. That's the way that I remember it because I honestly forget all the time. Alrighty. Are we good to move on? Great. This next part should be a lot of review. So y'all can shout out and let me know. Okay, we're going to talk about the different types of angles. Acute angles are angles that are measured less than 90 degrees. Very good. Measure less than 90 degrees. So what's an example? Give me a number less than 90. 50. Oh my gosh, good job. Right angles measure exactly 90. Oh gosh, 90 degrees. Okay. What do y'all know the little symbol that marks a 90-degree angle when they don't put the number 90? A square. A little square in the corner. Okay, that little square means 90 degrees. If there's anyone out there who's like, I literally don't know any of that, fine. That's great. Okay. Learn it. Okay. A cute little angle is tiny, a little cute. right? They're always right. They're always 90. Obtuse measures more than 90, but less than. Very good. Okay, so what's an example?
100.
100. Alrighty. A straight angle is going to be 180. Does it have to lie exactly vertical or horizontal? No. Bam. No, it has to be a straight line, but it could be diagonal. Okay, but it will measure 180 degrees. Okay. And then lastly, congruent angles. Congruent means equivalent, equal, same size, same shape. They are equal. Okay, so if I have this one angle that's 37 degrees, for a congruent angle, that angle has to be 37 degrees. It doesn't have to be facing the same way, but it's going to be 37 degrees as well. Two angles with the same degrees. UT? Moving on. I'm letting you already, but moving on. Okay, next we're going to get into naming triangles. I believe y'all know this, but again, refreshing just to have it on the top of our brain. We can give every triangle two names. I think of it as the first name and the last name, but what's cool about it is it doesn't matter which one's the first name and which one's the last name. Okay, we can classify them. We can classify them by their size and by their angles. Okay, a triangle, as we know, a triangle is a figure with how many sides and how many angles?
3.
Oh Lord, another real slow on the draw. Come on back. Good morning. 3 sides, 3 angles. And we can classify in two types of ways. First, we can classify them by their angles. So that's talking about their inside parts, like right here. Okay, classify them by their angles. It can either be an acute triangle, right triangle, or obtuse triangle. The way that I do this is every single triangle has two acute angles. Every single one has two acute angles. I look at the third angle to help me name it. Okay, I take my hand, I cover one acute angle, I cover another one. That third one, if the third angle is acute, then it's an acute triangle. If that third angle is right, then it's a right triangle. And then if that third one, after I cover the two acute, that third one is obtuse, then it's an obtuse triangle. Okay, so we can classify them by their angles. And in the acute triangle, again, every triangle has two acute angles. That third one is going to have the acute as well. So the number of acute angles is going to be 3. All 3 angles are going to be acute. They're all going to be less than, let's try that one more time. They're all going to be less than how many degrees? 90. Okay, all 3 angles will be less than 90. In a right triangle, the number of right angles is going to be just 1. It's going to have 2 acute, 1 right. For a obtuse triangle, every single one has 2 acute. That third one, the number of obtuse angles is going to be 1. Okay, but just an important note, every triangle, I'm going to put the triangle symbol, has at least 2 acute angles. Look at, you can put, like I mentioned, look at third angle to name it. We'll practice that in a second. Okay. Are we good? Did y'all learn this already in elementary? Okay. Maria?
What would your name be if it was backwards?
If it was what?
Backwards.
What do you mean backwards?
First name is last name and last name. What's your first name?
What's my first name?
Yeah.
Miss. Thank you. All right, by their sides. Okay, so we're looking on the lengths of the sides. They can either be equilateral, isosceles, or scalene. Equilateral means that the number of congruent sides, the number of equal sides is 3. Okay, a way to show that sides are the same length if they don't put numbers is with these tick marks. Okay, the tick marks show congruence. So since all 3 of those have the same number of tick marks, they would all be congruent. And the next one, the isosceles, how many sides do you see with the tick marks? 2. So only 2 are congruent. Okay? Again, they don't have to have the tick marks, but if they do, it's showing congruent. Then for a scalene triangle, that means that none are the same. Okay? Number of congruent sides is 0. They could put tick marks, and what that means is they might put like 1 here, 2, and then 3. Since none of them match up with a number of tick marks, that means none of them match up. You can also technically put these little tick marks on angles. So like on this triangle up here, I see that they all look about the same, like all these angles right here, they all look the same. If they were the same measures, they can put little tick marks on those angles as well. You're not going to see that too much this year, but in the future, you could. Okay? You can use those tick marks on other shapes too, like rectangles. I could say the top 2 are congruent and then the side 2 are congruent. I might, well, no, we haven't talked about those other shapes yet. So, cool. So, again, you can name every triangle with 2 names, by their angles or by their sides. One last little thing before we move on. I bet a lot of y'all have seen this from elementary school, but just in case you haven't. So again, in an equilateral triangle, equilateral, equal means equal. All the sides are equal. The way to remember that 3 sides are the same is because it has this 1, 2, 3 parallel lines. Have y'all seen that? Have y'all seen that before?
No.
Or is Miss Lyle just blowing your minds today?
Whoa.
By Anthony's reaction, I'm just mind blown. Okay? So you use the first letter again. Equilateral, 3 equal sides. With isosceles, how many are the same? 2, and there's 1, 2.
Oh my God.
All of them. And then scalene, it's a little loopy noodle. Okay, so none of them are the same. None of them are parallel, and so it has no. It's a noodle. I always think of it as a noodle. All right. Okay. So for those of y'all at home, this is going to be a little tricky. We'll summarize the activity in a second, but I'm going to do it with my class. So give me a second. Okay, so we have our triangles cut out. What you're going to do is you're going to highlight the corners. You don't need to highlight the whole triangle, but just a little bit on each edge. Alrighty, so now listen to my instructions before you carry these out. What's going to happen on your index card, you are going to cut those corners off. Notice that you're not just cutting off the color part, you're cutting the color with a little bit of white space. That's going to be very important. When you cut the 3 corners off, have a little bit of white space there when you cut, because what we're going to do in the next step, it's going to be hard to do if there's no white space. Okay, just cut off the 1, 2, 3 corners and keep those pieces. Do not lose your corners. Okay, in this last step, you are now going to try and put all the color pieces touching in the middle. Let's do this on your desk so that it's like, but notice how I took the 3 pieces and I have the color all touching in the middle. Right? So let's look. So looking at yours and looking at everyone else's, what do you notice about your shape? What do you notice?
A triangle.
It's not a triangle. Okay? It's not a trapezoid either, okay? Because like a trapezoid. Okay, so it does. Some of y'all might have 4 sides, but like we got 1, we got 2. I got like this little piece. It's not a trapezoid. That's not what we're trying to notice. But that all depends on how you cut. What do you notice, Michaela? But one more time, pretend we're talking. What's a half circle? You're correct. What's making half a circle? The colored part. Y'all notice that? Like you have they all sort of make a flat line on the bottom, and then they make a half circle. Like that? Do y'all notice that? So what, we just talked about something. What, and don't overthink it. What is straight and then 180 degrees? Correct? Okay? So, something that is unique about triangles is that no matter, did we all have the same type of triangle when we started? No. Okay, some of them were big, small, weird angles, okay? Any triangle, if it is a triangle, all 3 angles will add up to 180. You have that right triangle plus that middle triangle plus that left triangle. No matter what, when you add up the 3 angles, it will always equal 180. Okay, so that's the summary of that little exploration. We'll clean up in a second, but let's keep moving. All right, so yes, we have more notes. To sum up that little exploration, the sum, meaning when we do what operation? The adding of the measures of the angles of any triangle will always be how much? 180. Again, we're talking about the angles, not about the side lengths. There's no special, they all add up. No, side lengths of triangles will all be different. Okay, but the angles will always add up to 180. So you can say that x plus y plus z will always equal 180. This is another equation. So what we're going to do is we're going to determine this missing angle in each of these triangles. I'll do one with you, and then you can do the other. It says to write and solve an equation to determine the value of x. So I need to write the equation. I also need to solve for that missing value. So does anyone want to try to write the equation, or do y'all want me to do the first one? Carolyn?
Angle x plus 38 plus 5.
Yep. Equals 180. Go ahead and copy that down. I'm not going to be too picky about you writing the measured angle x. If you just wrote the letter x, I would totally be okay with that. Just know that as we move up in math, they will start having you write it in that way. I love that we're already catching on to it. Okay? So, thinking now about like terms. Can I add this x plus the 38? No, I can't do that. Can I add 38 plus 55? Absolutely. Okay? 38 plus 55, take a second. Measure of angle x plus how much?
93.
93 is equal to 180. And then how do I solve for x? Subtract 93, take a second.
So 180 minus 5.
Correct.
Equals.
That's what everyone's solving, Michael, right now. They're doing it quietly, though. Okay, what does it equal? 87 degrees. Okay, now, looking at that, did anyone think, oh, that's 90 degrees? Did anyone see that angle and was like, oh, 90? Does anyone see how that's really close to 90? Okay, but we cannot, because one measure of difference, like 79 is not equal to 80. 90 degrees is not equal to 87 degrees. You cannot just assume, hey, it looks like this kind of angle, I'm going to put this number. There is math calculations in order to do that. Okay, so does the answer make sense? Does 87 make sense? Yes, I would say, like in my mind, I would say it looks about 90 degrees, and my answer is close to that. My answer is close. Okay, like it's just justifying, yeah, that makes reasonable sense. If you remember, like our problem solving strategies, checking the reasonableness of our answer is a big thing that CAP students don't do, because they're like, I must finish. Okay, y'all don't go big, and you're like, oh, that makes sense, because when you get your test back and you miss a question, half the time you're like, what was I thinking? Okay, it's that reasonableness check. Okay, go ahead and do the other two. Pause and play when you're ready. All right, can someone give me the equation for the next one? Taki, go for it.
Measure of angle x plus 22 plus 51.
Very good. There might be tickets where you have to write the equation, so make sure I know a lot of y'all like just add them and subtract it from 180. Make sure you know how to write that equation because you could see it. When we add 42 and 51 class, we get and then you'll notice, oh my god, Miss Idle, we just did this problem. The measured angle x is equal to 87. Okay, but it looks different. Okay, I would still say the same thing, unless, did anyone have a different justification for their answer? Okay, but it's pretty much the same. Yes, you had a different one?
Yeah.
What did you say?
It was right.
Got it. It's not right because it's not 90 degrees.
How do you
Got
get
it.
that n?
Huh?
The n.
Again, this is the way that they write, whenever we write like measure of angle x, what that translates to in words is the measure of angle x. Like that's what you would say. But just like y'all were lazy, mathematicians are lazy and they don't want to write out a whole sentence, so they just use an n for measure, an angle symbol for an angle, and then the angle we're talking about, measure angle x. You'll get used to it after a while. this is the first day that y'all are seeing it, so it's gonna look like gibberish, a new language. I'm typing in that font, I know what I'm saying. Okay, next one. Volunteer. Marcelo, go for it. Measure of angle X. Okay. 40. I'm trying to write that number. 141. Oh my gosh, equals 180. Marcelo, when you added those two, what did you get? 158. And then when you subtracted from 180, what did you get? 22. Do y'all agree with that? Okay. I probably wouldn't say that it looks like a right angle. I said it looks like an acute, and 22 is less than acute. Looks like a cutie. Okay. Real quick before we do move on, if Miss Lytle wrote 17 plus the measure of angle X plus 141, would that be a correct equation? If I change the order on this side, would that be okay? If I wrote 141 plus the measure of angle X plus 17 equals 180, would that be correct? Okay. If I put the 180 on this side instead of on this side, would that still be correct? Yes. Okay. I just want to make sure that when you see the, oh my God, it's a different order. It's still okay. We Gucci? Okay. The last part is the most fun part, okay? Because we're going to go into this knowing not a lot, and we're going to come out knowing a lot more than we did. Okay. This last problem. We are looking at a triangle. I see it this level. Okay, it says let's solve this thing. Okay, it says an acute equilateral triangle can be divided in half with a segment from the vertex to the middle of the opposite side. What types of triangles are formed? Meaning we need to classify. We need to name the two triangles that are formed when I cut it at that line, and we want to know what are the angle measures of the two new triangles. Now, Miss Lytle, do I have any side lengths on there? Do I have any angle measures on there? No. I got a lot of nothing. I got a dotted line down the middle of the triangle. Okay? But at the end of this, I know. Okay? At the end of this, we're going to know a lot about this. Okay? So let's break it down. Whenever you get to a problem where there's a lot that they're asking and you don't know a lot, break it down. So I see that it's an acute equilateral triangle. Acute means all of the angles are less than 90, and equilateral means all equal sides. Okay, so I'm going to go ahead and mark that all, like the angles, that doesn't really help me because there's a bunch of different combinations that could get each one. But I do know that all the sides are equal. Let's start there. Okay, I'm going to put a little tick mark showing that all the sides are equal. Okay, let's critically think about this. If all of the sides are equal, what do you think that means about the angles? They're all going to be equal as well, okay? Because the angle, how much it's open, controls how long the sides are, right? So if all of the sides are the same, that means all of the angles are going to be the same. So if I said, because I don't know, if I call this angle X, what could I call this? X. And then this one up here, X. What equation could I write to find the angles? What we just practiced, all angles add up to 180. So let's write an equation based off of that. We're going to take it one step back. We're going to say X plus X plus X is equal to 180. Okay, and then Anthony and Andrew both just said X plus X plus X is the same thing as 3X, right? It's the same thing. So let's say that 3X is equal to 180. How do I get X by itself? Divide both sides by 3. Is that ringing a bell, y'all?
Yes.
And then X is equal to 60, meaning the angles are equal to 60. Yes. Pause. Pause that thought, okay? There's some extra talking points going on, okay? Pause. We are going to get there, and I will come back to you in just a second. So I'm going to go ahead and label all of these as 60 degrees. 60, 60, and 60. Okay, so we've taken care of that acute equilateral triangle, and then it says divided in half with a segment. So Saki, go ahead and say again what you were saying.
90 degrees thing on the bottom?
So let's pause there, okay, because we're not quite there yet. So this line, she said it splits it in the middle. Okay, that line segment is cutting it in half. So if I say, okay, I'm just gonna take that right side of that triangle, okay? I just cut this top angle in half. It was 60, now it's gonna be 30. Okay, that's gonna be 30. Go ahead and draw this one off to the side, 30. I also, did this angle over here change at all? No. Okay, that one's gonna be 60. Okay, now, I don't know anything about this other one, technically. I don't know, but how can I solve for it? I know that all three angles add up to 180. 30 plus 60 is 90, so the x plus 90 is equal to 180. X is going to equal 90. That is going to mean it's a right angle. Are you all following that train of thought? Okay. This one is like a lot of like, okay, I have to take this piece of information and this piece of information. Okay.
Did we split it?
So that's this side. What about the other side of that triangle? Same exact thing. That's the other half of that 60. This is 60, and that also is 90. Okay. So acute equilateral triangle, we split it in half from there, and it wants to know what kinds of triangles are formed. These two triangles are congruent because they are the same size, same shape. Now we just need to name them. So let's name them by their side or their angle lengths. Okay, every single triangle has how many acute angles? 2. So I'm going to cover up any 2 acute angles. What are 2 of the acute angles? 30 and 60. That third one is 90. So that means it's going to be a right triangle. And then let's do it by its sides. Now, again, I still don't know any of my side lengths, but my angle measures. Are any of the angle measures the same? One more time. Are any of the angle measures in this form triangle the same? No. So what could we assume about the side lengths? Scaling, right? Scaling triangle. Okay. Could I switch those names? Could I put scaling right? Absolutely. It does not make a difference. Put that. Okay. So that's definitely a spicier one, and that's why we walked through it because there was a lot of pieces to that puzzle. But hopefully you were able to follow all of that. Okay. So what's going to happen now, I think, is a lot of classwork, extra practice and stuff like that. While y'all are working through this, I'm going to play the brain pop video, and I'm going to record it so that the people at home can also enjoy the brain pop. But just work through these problems. This weekend technically is a no homework weekend. Okay. So I'm not assigning this, but do you think this equation is eventually going to come up on a test or a quiz? Of course. Okay. So I would maybe choose like half. Again, I am not assigning it. I will not be checking it on Tuesday. If Mikhail does check it on Tuesday, we don't miss one. Okay, but don't actually look. Okay. Let's be like, Mikhail, I recall. Okay. So I'm going to record that video. Let me pull it up, and then I'll record it in the today's program.
Strike? You're nuts. Okay, time out. Dear Tim and Moby, I need to draw all the types of triangles. Can you help? From Liza. A triangle is any three-sided polygon. A triangle's 3 angles always add up to 180 degrees. We classify triangles by both their angles and by the lengths of their sides. Equilateral triangles have 3 sides of equal length. Since the sides are equal, the angles of an equilateral triangle all measure 60 degrees. Isosceles triangles have at least 2 sides that are the same length. At least 2 of the angles will be equal as well. Scalene triangles have 3 sides of different lengths. Every angle in a scalene triangle is different from every other angle. Correct. Equilateral, isosceles, and scalene triangles are all classified by comparing the lengths of their sides. Yep, I did say that we also classify triangles by comparing their angles. Let's take a look at those. Right triangles have one right angle that measures 90 degrees. The long side of a right triangle is called the hypotenuse, and the 2 sides that form the right angle are called the lengths. Acute triangles have 3 acute angles. An acute angle is one that measures less than 90 degrees. Obtuse triangles have 1 obtuse angle. An obtuse angle is any angle that measures more than 90 degrees. So we've got 6 types of triangles. Those that are classified by comparing their sides, equilateral, isosceles, and scaling triangles. And those that are classified by comparing their angles, right, acute, and obtuse triangles.
All right, that's going to be the end. There's more to the video, but it goes into stuff that we don't need. Again, this homework, I know on this first one, I would look at the homework key if you're having trouble writing the equation. Once you see it, you'll be like, oh, okay. But that is this weekend. Make sure Imagine Math, you can work on that as well.